The Barber Paradox. The barber is the one who shaves all those, and those only, who do not shave themselves. The question is, does the barber shave himself? Any answer to this question results in a contradiction. The barber cannot shave himself, as he only shaves those who do not shave themselves. Thus, if he shaves himself, he ceases to be the specified barber. Conversely, if the barber does not shave himself, then he fits into the group of people who would be shaved by the specific barber, and thus, as that barber, he must shave himself. Barber Paradox. Consider the expression, the smallest positive integer not definable in under 60 letters. Since there are only 26 letters in the English alphabet, there are finitely many phrases under 60 letters, and hence finitely many positive integers that are defined by phrases of under 60 letters. Since there are infinitely many positive integers, this means that there are positive integers that cannot be defined by phrases of under 60 letters. If there are positive integers that satisfy a given property, then there is a smallest positive integer that satisfies that property. Therefore, there is a smallest positive integer satisfying the property not definable in under 60 letters. This is the integer to which the above expression refers, but the above expression is only 57 letters long. Therefore, it is definable in under 60 letters and is not the smallest positive integer not definable in under 60 letters, and is not defined by this expression. This is a paradox. There must be an integer defined by this expression, but since the expression is self-contradictory, any integer it defines is definable in under 60 letters, there cannot be any integer defined by it. The Crocodile Dilemma. The premise states that a crocodile, who has stolen a child, promises the parent that their child will be returned if, and only if, they correctly predict what the crocodile will do next. The transaction is logically smooth, but unpredictable if the parent guesses that the child will be returned. However, a dilemma arises for the crocodile if the parent guesses that the child will not be returned. If the crocodile decides to keep the child, he violates his terms. The parent's prediction has been validated, and the child should be returned. However, in the case that the crocodile decides to give the child back, he still violates his terms. Even this decision is based on the previous result. The parent's prediction has been falsified, and the child should not be returned. The question of what the crocodile should do is therefore paradoxical, and there is no justifiable solution. The Court. The story is related by the Latin author Aulus Gellius in Attic Nights, who says that the famous sophist Protagoras took on a promising pupil, Euryalus, on the understanding that the student would pay Protagoras for his instruction after he wins his first court case. After receiving instruction, Euryalus decides not to enter the profession of law, opting for politics instead. Consequently, Protagoras decides to sue Euryalus for the amount he was owed. Protagoras argued that if he won the case, he would be paid his money. If Euryalus won the case, Protagoras would still be paid according to the original contract, because Euryalus would have won his first case. Euryalus, however, claimed that if he won, then by the court's decision he would not have to pay Protagoras. On the other hand, if Protagoras won, then Euryalus would still not have won a case and would therefore not be obliged to pay. The question is, then, which of the two men is in the right? Curry's Paradox. Curry's paradox is a paradoxical conclusion derived from the statement, if this statement is true, then mermaids exist. Instead of the existence of mermaids, any implausible or false statement can be used. In the English original, the existence of Santa Claus. The reasoning leading to the paradox goes like this. Let us denote the statement as, if this statement is true, then mermaids exist. We don't know if the statement is true, but if the statement were theoretically true, then this would entail the existence of mermaids. But this is precisely what is stated in the statement. Therefore, mermaids exist. Liar's Paradox. The Liar's Paradox is a family of logical paradoxes, the classic version of which states, I am lying, or more precisely, this statement is false. If we assume that the statement is true, then because it says it is false, which is a contradiction. Conversely, if we assume its falsity, then it corresponds to what it says itself, and therefore, it's true, which is also a contradiction. The essence of the paradox is self-reference, that is, the statement's pointing to itself. An early statement similar to the liar paradox is attributed to the ancient Greek philosopher of the 7th century BC, Epimenides. All Cretans are liars. Since Epimenides is a Cretan, the statement is similar to the liar paradox. The question is, what the negation of the statement Cretans always lie is. If it is Cretans never lie, then the paradox holds. If it is Cretans do not always lie, as is usually believed in logic, then Epimenides' statement is simply false, and there is no paradox. The phrase, "I know that I know nothing," famously attributed to Socrates, presents a paradox because it makes a self-contradictory claim about knowledge. The contradiction arises because if the speaker truly knows that they know nothing, then they must know at least one thing, namely that they know nothing. This creates a paradox because it implies possessing knowledge, knowing nothing, while simultaneously denying any knowledge, knowing nothing. Similar is the knower paradox. It belongs to the family of self-reference paradoxes, like the liar paradox. Informally, it consists of considering a sentence saying of itself that it is not known, and apparently deriving the contradiction that such a sentence is both not known and known. The opposite day. Opposite day is a make-believe game, usually played by children. Conceptually, opposite day is a holiday where things are said and done in an opposite manner. It's not a holiday on any calendar, and therefore one can declare that any day of the year is opposite day, sometimes retroactively to indicate something which will be said, or has just been said, should be understood opposite to its original meaning, similar to the practice of crossed fingers to automatically nullify promises. Now, if a person says, "It's opposite day today," then it is not opposite day. But if you say it is a normal day, it would be considered a normal day, which contradicts the fact that it had previously been stated that it is opposite day. Richard's paradox. The original statement of the paradox, due to Richard, 1905, is strongly related to Cantor's diagonal argument on the uncountability of the set of real numbers. The paradox begins with the observation that certain expressions of natural language define real numbers unambiguously, while other expressions of natural language do not. For example, the real number the integer part of which is 17 and the nth decimal place of which is 0 if n is even and 1 if n is odd, defines the real number 17.1010101 equals 1693 over 99, whereas the phrase "the capital of England" does not define a real number, nor does the phrase "the smallest positive integer not definable in under 60 letters. Remember Barry's paradox? Russell's paradox. According to the unrestricted comprehension principle, for any sufficiently well-defined property, there is the set of all and only the objects that have that property. Let R be the set of all sets that are not numbers themselves. If R is not a member of itself, then its definition entails that it is a member of itself. Yet, if it is a member of itself, then it's not a member of itself, since it is the set of all sets that are not members of themselves. The resulting contradiction is Russell's paradox. Theseus's paradox. The ship of Theseus, also known as Theseus's paradox, is a thought experiment and paradox about whether an object remains the same after all its original components have been replaced over time, typically one after the other. In Greek mythology, Theseus, the mythical king of Athens, rescued the children of Athens from King Minos after slaying the Minotaur, and then escaped on a ship to Delos. Each year, the Athenians would commemorate this by taking the ship on a pilgrimage to Delos to honor Apollo. Ancient philosophers raised a question: after several hundred years of maintenance, if each individual piece of the ship of Theseus was replaced one after the other, was it still the same ship? Paradox of the Heap. The Socrates paradox, also known as the paradox of the heap, arises from vague predicates. A typical formulation involves a heap of sand from which grains are removed individually. assuming that removing a single grain does not cause a heap to cease being considered a heap. The paradox emerges when this process is repeated until only one grain remains. Is it still a heap? If not, when did it change from a heap to a non-heap? Schrödinger's cat. Erwin Schrödinger once wrote, "One can contrive even completely burlesque, farcical cases. A cat is put in a steel chamber along with the following infernal device, which must be secured against direct interference by the cat. In a Geiger counter, there is a tiny amount of radioactive substance, so tiny that in the course of an hour, one of the atoms will perhaps decay, but also with equal probability that none of them will. If it does happen, the counter too will discharge and through a relay release a hammer that will shatter a small flask of hydrocyanic acid. If one has left this entire system to itself for an hour, one would tell oneself that the cat is still alive, if no atom has decayed in the meantime. Even a single atomic decay would have poisoned it. The psi function of the entire system would express this by having it in the living and dead cat, pardon the expression, mixed or spread out in equal parts. It is typical of these cases that an indeterminacy originally restricted to the atomic domain turns into a sensually observable macroscopic interdeterminacy, which can then be resolved by direct observation. This prevents us from so naively accepting a blurred model as a representative of reality. Per se, it would not embody anything unclear or contradictory. There is a difference between a shaky or out-of-focus photograph and a snapshot of clouds and fog banks.